Hello, everybody. I hope you are sitting comfortable at home or at work. It's so nice to see many of you participating in the Airflow Summit. So I really hope you enjoyed the session. So yeah, I've been working for the analytics team at LOVOO for the last 2 years, and today I will tell you how was the perfect match, Airflow the perfect match in our analytics pipeline. So for today, I've prepared this nice agenda, and it relates something similar. So when you are telling a love story, but first, before we start, I would like just to tell you a little bit more about LOVOO. So LOVOO is a dating app, and a place for chatting, live streaming, watching stream, getting to know people, flirting, and so on and so on. We are based in Germany. We have headquarters in Dresden and in Berlin. We were founded in 2011, acquired by the Meet Group back in 2017. We are right now in the top three dating app here in Europe. We store in our data warehouse around 280 terabytes of data. We are growing in a rate of 6 terabytes monthly. And to give you an idea, we have like aggregated data daily, and we are processing around 3 terabytes daily. As well, like the sum of the two biggest tables in our data warehouse are around 36 terabytes. So it's really big data what we are handling daily with Airflow. So um, telling you about my team, we are six data analysts, two BI architects, and one head. Um, we strive to improve the value that LOVOO is bringing to the users by bringing data-informed recommendations to teams across the whole organization. So in this case, we have the stakeholders like product, finance, marketing, talent management, customer insights, and CRM. So we measure and monitor different metrics. We do ad hoc analyzing, and we do dashboard reporting, enabling and encouraging the rapid iteration for an evidence-based decision making. So, what can you expect of this talk? So, when I started back in 2017, I was like completely new with Airflow, and I just didn't have much experience working with orchestration tools. So I think, and I think it's really interesting to have these kind of talks because probably if you are in the position I was back in 2017, it would be like a really nice thing to see, or I really would have expect to see something like this. So my purpose today is to tell you about our journey with Airflow and some different use cases that we have right now, we have implemented with the time, and that probably you can use it in your analytics team, or you just can get some ideas of the different use cases. So I have different piece of code, some really easy examples. I would just try to keep it so easy as possible. Well, I will have too many screenshots, but yeah, so let's start it. So why we met Airflow? So back in 2017, when I just arrived to the company, we had a classic uh, on-premise infrastructure with Hadoop. Back then we were used to put all our workflows in UC, but we wanted to be the cool kids, right? So we went to the cloud, and we started to use the different components from the Google Cloud, like BigQuery, the Kubernetes, virtual machines, also using the Google Cloud Composer that I just will talk later about it. And to make you like, or like to show you a rough picture of how our data architecture looks like, or the data processing pipeline, it's basically like this. So users are flirting, are writing with somebody else, are watching live streams. So at every single interaction the user has with LOVOO will produce an event that will be then stored in the backend, and will be and it will be then storage in BigQuery after going for a data loading with all the GDPR compliances happening, where the anti-spamming and the different other services that are interacting with the events are taking place. But we will focus today in this part that is basically like I would say like a business intelligence architecture. I would say it like this. So we have, as I already mentioned, BigQuery, where we are having like the staging data, and we are doing aggregations over the different tables that we're having of the different events that are coming, and at the same time we are scheduling and like batching the different data from the different data sources with Airflow. So we have AppSolver, Adjust, the different payment providers, Google Firebase, and everything will be aggregated daily, and then will be then the information will be then used for the ad hoc analysis or Tableau dashboards, and so on. So yeah, but who was really how we met Airflow? So how was that sparkling moment? That sparkling moment started when we just realized that in the migration we needed to find like a replacement for Uzi. That was the first time we were doing a migration, or at least me. I realized, okay, we just need to see what is out there. So I started to research a little bit, and I just had these points there, like identifying what is out there, how much does it cost, the scalability, the compatibility with the different data sources that we had before. Also, to have the knowledge and the human resources. So yes, I was really really new, and I did my research and then landed with Airflow, and then realized that. I found that they were in that incubator project and the success story from Airbnb, and for me, in 2017 was something new, but it sounded really really promising. So yeah, I just discovered that it had a really great roadmap, good support, great community. It was a game changer, definitely. Also, the environment was like in a mobile app. Um, Everything was in Python, and yeah, it has like some operators that were already compatible with our data warehouse, so with BigQuery. So after discussing with the team, we just decided, okay, let's do it. Let's use Airflow. uh, and that was the time when we also got into the beta project, alpha project, actually alpha project from Google Cloud Composer. That is like the fully managed Airflow. I'm sure you heard about Cloud Composer in the past sessions. So yeah, so we discovered it's a fully managed Airflow. It's scalable, it's secured, it's using this identity aware proxy, and then we also could focus on building the analytics data pipeline, and also was easy to implement. At that time was an alpha version, but we took the decision to take the risk. Um, yeah, we started working with Airflow, fully Airflow managed in an alpha version for Cloud Composer. So yeah, we liked each other very much. We had our first date. So how it looks our first date like? So we had that to do list, and that back at that time we had a lot of different SQL scripts. So we used the time to do a little bit of cleanup, start a little bit like from scratch, having new data modeling, and like refactor the different SQL scripts. As we started writing the different DAX, we configured the Cloud Composer. Then we set that all the permissions. We refactor also the data importers. Our first question after we had that part done was like, okay, how do we deploy? So here basically started one of the interesting things we did back at that time. So for this, we also got some help from the infrastructure guys that have probably of course more knowledge than me, like working with YAML or with Kubernetes and Google Cloud Build and this stuff. So basically what we did with our CI/CD was having all our scripts and our DAX written or storage in a version controlling software, in this case GitHub. And every time a user or an analyst or a BI architect will do a commit or a PR, it just will be automatically checking the code, like a flake will check those syntax and also uh, deploy that on a Docker image and see if there is any error with the new tags or with the SQL files. After this and merging into the branch master, we then have a trigger with Google Cloud Build. And Google Cloud Build is configured, or that deployment is configured with the YAML file that it tells, like, please Google Cloud build all the, or move all the files, so transfer to the cloud storage. And that's basically what we had in the beginning, and it's actually still working like that. We did some small improvements, so every time that the Google Cloud Build will be done, it just tell us, okay, either if the like it, if the whole process is getting or is working, is being successful or not. So we are getting notified at a good time. So at that time, now having gone through the first date, we had a really lot of nice new date. So we started to build out of it like a new whole environment out, like surrounded with Airflow. So we started then to create our different DAX. So we have been growing different DAX. We have used different components or concepts that Airflow offers, like subDAX, using branching, Jinja templating. The Jinja templating is basically really useful for us in the manner that we use the data partition tables. So these data just allow us to backfill the different data dynamically and whenever we want, using hooks, pulls, and different trigger rules. And up there, you can find all the different operators we use the most. So yeah, so we basically are having a main analytics pipeline, and it's being scheduled daily, where we do all the batch aggregations. We do, of course, run different other pipelines, but mainly we focus on this one this time. At this time, what you have here is like we have a mm, different time range external task sensors, and what they do is like they represent, every single one of them represent another external DAG with a task at the end is called finished, and this task will be waiting for that task to finish. So we have all different dependencies here, and until all of them are marked as success, we just gonna start with the first level and the second level, and so on and so forth. So here, to make you more an idea, this is like one of the this is the content of one of the subtasks. So it looks pretty from the inside as well from the outside, as we'll show you. So basically, this pipeline is built with different BigQuery operators. And with these BigQuery operators, we basically have all our SQL scripts, and we are scheduling them, and doing the different aggregations. We also found out a really interesting way how to grade the DAX with this dummy task in between. We had a better overview, and we could escalate and add easily more tasks individually. Yeah, so we started then to implement some other new operators, like the batch operators in this case. So when we get all our aggregations on all the different tasks or the dependencies before of sending one report, we just get notified with this with this with a notification in Slack. So how we do that? So we have basically a batch operator. This batch operator goes and send a request, a post request to a Slack webhook, and the Slack webhook tell us, hey, the reports are there, and then we check them manually, and we decide whether to send them or not. So this is pretty useful for this case, sending reports. Also, one of the problems we had before was, well, we used different Tableau extracts, and they were scheduled like in a certain time every day. So sometimes you have delays on the pipeline, and you probably can, like, oh, you really need to do again, like manually trigger the structs again if the data is missing. So what we did was creating also a post request with a service that we have in the server, and we were triggering this track. So that was really, really, really helpful as well. Yeah, and as probably you already saw, we have this notify task within a Slack API post operator that is basically interacting all the time with Slack and letting us know when a DAG is finished, when the pipeline is finished, and so on. So we basically have that thing daily popping up in one of our channels and letting us know whether a pipeline is where a DAG is done or not. But yeah, sometimes things goes wrong, and we also use that Slack API operator for doing kind of like error alerting when something was when something was going wrong. In this case, we used this other arguments on failure recallback, and on that we just used inside of that we just used Slack API post operator. So we just configure that and we are using the context to send the information back to Airflow and letting us know, okay, something went wrong, just please go and take an action. Yeah, so one most of the times what we are doing is like we are using Python operators. So I want to show you quickly, like in a rough picture, how we do the different data source integration. So here in this case, we have Amazon Redshift, mm, and we have, for example, normally a Python operator, and this Python operator has a Python callable. In this callable, we have then we call another function, but we send these different parameters that will be deployed or that they will be templated in the runtime. In this case, they're templates dictionary. We have the execution day, so we have the partition for the table, and we can send other extra parameters. So this one is the function I just talked about, and we are doing is like we are also getting the templated data and send it directly for to the import data like Redshift data function that is like a custom code that we have written. In this case, what is going to happen inside the custom code is like we define a Postgres SQL connection. We use that comes off from the hooks, so we get base hooks and we get the connection like the connection password to like to avoid exposing the passwords and the different credentials in the code. So that's pretty useful, and it's really fast to do. So yeah, so we basically create a password connection, the cursors and the connection, and we use it in our function that is going to be triggered from the Python operator. At the end, we just create a SQL dynamically, depending of the table of the name, or depending also like a where statement where you are selecting a specific date from the data. We then request that data with the SQL which is generated. And yeah, from that on, you just can basically use data frames or CSV files or whatever you find it better for you. In this case, we are working with pandas and a data frame, and we're just using a BigQuery job that is uploading the data back to BigQuery. This is how, for example, in this case, the integration looks like, or the DAG looks like. In this case, we are having two different DAGs, load table transaction groups. I mean, we're loading two different tables, but we are also loading 2 days in the past. So we know that we have some changes in the day before yesterday. So we also load them and then do the different aggregations at the end. So yeah, we are mainly scheduling all our custom developed data imports with the Python operator. So we have developed for Redshift, as I already showed, Firebase that is working also really dynamic, Google Cloud Storage, also G Sheets, AppSumer, Shopify, PayPal. Also, a few weeks ago, we also used the S3 storage. We are also bringing data from the S3 storage, putting into the Google bucket storage, and importing back to BigQuery. So yeah, is there any dynamic in between? And by this, I'm not necessarily referring to the relationship between Airflow and our infrastructure, or our team, but because I have been showing specific use cases where we always needed to write task by task. I really would like to show you how we are creating tasks dynamically. Um, and so yeah, so first we are not triggering all these tasks at the same time, but yeah, they are being generated in the DAC, and they will be shown like this. So we use this concept really often when we have different use cases. When we, for example, in this case, we need to import a lot of events, and they are coming and coming after, and we don't want to write them manually. And they have it's like will be like every time being doing a copy paste. So how we do that? I We just came up with this solution, um, and we are not writing that much code anymore. And this is like a basic, like a three-step concept. So I figured out writing a plain text with a meaningful structure will help to do that. Like we just every time we just add a new event, we just need to add one line to the file. We use a Python operator for that, and we have our function or our custom code that we just gonna call from the Python operator. In this case, we have a specific case. We have Absolver. Absolver is delivering us JSON line files into the bucket storage. For every single event we are receiving on that bucket storage, we have the unique identifier, and followed by a different path that are basically like the date, like 2020. Uh, 07 is backslash the month backslash the minute, and whatever. It's something like this. After that, then our Python that I will actually is going to show you how it works. So after that, we just and then start creating the different tags dynamically. So how it works here, this JSON file is basically what I was telling you about. You just define a file like this. You can, of course, do it how you really need to do it. In this case, we have the name of the event, a specific ID, and probably the format if they will be probably changing. We also can work with Abra files, for example. So after defining that, um, you just create a for looping that will go through that file and creating the task IDs dynamically. That will be every single name of every single event. And after doing that looping, it would just create a lot of tags that you already saw with these parameters. But basically, as one of the important things is like using the parameters like that are gonna be the input parameters for the function. In this case, the execution date, the event name, which data set, like the destination data set, also the bucket name. Yeah, so this is then the function is also written in the DAG, and this one is again doing back the different getting the different variables from the context and sending it over to the import GCS to be query function that we have customized. So in this one, basically, what will happen is like we have this event mapping that is the JSON file. We also have then we identified, or we just match the table name or the event name with the ID, and with that ID basically we just build the path, and we generate an array with all these paths, or with all the files that, for example, the bucket storage has. For example, we just want to do 2020 for January 1st, and then it just match all the files that have that date, and it's just gonna be like put inside of an array, and all this array containing all these different paths from the files are then being the parameters for the load table from URE function that is basically from Python, and the Python client from BigQuery that is loading all the different files to BigQuery. Yeah, so at the end we are having that schedule. Every time we need to add a new event, it's just really easy. We just don't need to worry that much writing our tasks manually. And this is, for example, how it's working with this. So yeah, until this time, then I show you how we are using Airflow for different use cases, being really flexible and like giving us a lot of different chances to yeah, like to load different and integrating different data sources. So we have now the recap and the conclusion. So yeah, I was barely mentioning this one when I was writing my paper for calls, the call for papers, and then I just realized, yeah, Kubernetes pod operator. We were using it, and I've seen that a lot of people is really interested on this because it's really powerful. Um, but what did I put this one into the recap and the conclusion? It's just because we just learned that, I mean, we were like kind of over engineering the way we were using this operator. Why? Because we just needed to import, for example, from AppSumer 30 days. And from these 30 days, we needed to use different dependencies and create a really complex process and API and fetching data and so on and so on. That was pretty complex. And what we were trying to isolate all that environment with the Kubernetes pod operator. But we were having a lot of problems, so it wasn't being with that really good performance at all. We just decided like to see if we could find another way, so we ended up adding the dependencies to the cloud composer, like doing basically this pip install and installing the packages. um, and we realized that that was working better and faster, and we wouldn't, I mean, even though we didn't have an isolated how do you say, like, pod running the task, it was working better. So in that case, I think if it is, yes, really powerful, but we just learn probably to don't overdo it, because we just probably can solve problems in a different way that we're gonna be faster. And for example, I know that this is really powerful, and I know that there are more complex cases where you really can use it. So go straight and try the basic operators. If these basic operators just don't work, go for a complex for more complex ones, and at the end, well, try to isolate all what you can, or like try to put a different uh, for example, using everything in a pod. And that's something we learn. That's basically the experience we have with the Kubernetes pod operator. And also, you need the expertise. You need really somebody who really knows how to work with it. That's also the case we didn't have. Yeah. So yeah, I just want to share that when we needed to use that cloud composer in a beta version, in an alpha version, actually was pretty complex in the way that if an alpha version is there, is coming a new one that will be the beta version, and after that is coming an official version. And yeah, at that time, those environments didn't have any possibility to migrate from one and another, and we did know that. So well, we decided to go on that. So it was pretty challenging, because we need to do basically three migrations from the same Airflow. Well, we learned a lot as well, but well, that was the risk we took. Yeah, that having a fully managed Airflow gave us all the opportunity to focus on the pipeline, to factor our SQL, to think better how we can improve our pipeline. And I was commenting you, yeah, it's really nice how Airflow is like having a lot of built-in operators just out of the box. You just can use them and start your pipeline. It's amazing how fast it goes if you just read a little bit of documentation. That for us was really helpful, having these built-in operators. And yeah, we discovered that a lot of room for improvement. You can always do things better, like get things more automated. Yeah, we probably also could use some of the ideas that the other different speakers have been showing. Really nice ideas and really nice projects out there. And yeah, I will just tell you there is not a specific magic recipe. uh, how to start your analytics pipeline with Airflow, or how to use it. So you can really stay flexible. You can use what you have, the knowledge you have. Um, and yeah, I think that's all what we have learned and with Airflow, and we are really proud to use Airflow actually since 3 years, and we are happy with it. So yeah, that's all for today. Thank you very much. I hope you really like it and you just can take some ideas home. Thank you very much.